Hi everybody, I want to talk a little bit about today, Lab 11. First cover some OOP concepts, object-oriented concepts. We want to go over what is a class, what is an object, give you a nice example of that, okay? Class is simply a blueprint for which individual objects are created. And what the cool thing is that you can express however you want to the class, however you want to structure it. So it's like a structure actually, but it has some really nice features in addition to what we went over before in the structure. Example, school, vehicle, building, invoice, rectangle, circle, fraction. This can be like a noun type, which you would think is a noun. That's a good way to start thinking, what would I name my class? What's an object? Well, it's a representation of a class. So a class can be a type of car. So I could have a mom's car or a dad's car as an object type. A boat, a student, a rectangle. Notice a class has both a state and a behavior. So, excuse me, you're sort of modeling around that logic when you have your object-oriented program. And behavior is usually what is called a method or methods. And you have attributes, which are data members. Think of those like descriptors to help define the object. What kind of attributes can I have for some car object? Well, I can have doors, color, MPG, trim, make, model, year, string, etc. However you want to make it. And we can have data types, of course, for those representative attributes. Now here's a behavior. I want to get color or I want to set color. Sometimes we use the word get and set in the industry because that would represent some access like get something, get color, or some like a mutator, what is called a changing feature to a particular value. So we use that function set color to maybe set or change or update or whatever some object's attribute there, member attribute, color. Maybe I have something to calculate. I don't necessarily have to use the words get and set, but I want to calculate the miles per gallon. Here's a great example, mom's car versus maybe dad's car. Mom's car is a basic car there, 4 doors, red, 20 mpg, 2 liter. Ford is the make, and the model will be Taurus. Year is 2010, 6-cylinder. Anytime we want to call a method of the class, we use the name of the object. So mom's car, dot get color. Maybe I got dad's car, dot set color. Here's a nice model to show what an object represents. A name, got to have a name. Mom's car, dad's car. How maybe they interconnect and interrelate. Here's a great example of that. Sure, we can have something here that can be a simple program without a class. I don't necessarily need a class to calculate a rectangle, do we? I can get the length and width of from the user, and I can make, of course, a calculation for area. I could have a function for that. I could calculate perimeter and stuff like that. I can do everything here without a class. But why do we use a class? Well, again, the object-oriented logic. Here's a great example of fractions. And you notice here I could have a few fractions, and I could sum two fractions. Very easily done with objects. What does a fraction have? Well, it has a numerator and a denominator. I could subtract them, get the products of them, and get the division. So look at main, how clean it is. One thing that's nice is that we can have all that fussy stuff, all that frivolous stuff, whatever you think, in another area. I can even define it in another file. Sweet. There's that definition of a class. As I progress further here, please check a little bit the extras here. These are great terms to know. I mentioned some of these here that are very important. That's labeled out in the book and all that stuff in the slides. So we want to make sure we sort of get the hang of things. This is important here. Our access specifiers, notice we can have like public and private. By default, our data members are going to be private, and our members are going to be here. Helps to spell a little bit too. Let's put this right sort of feature there, colorized for you. Method members are going to be normally public for access, but we want to keep data members private, okay? That's going to be very, very important. We don't want just anybody, any class or any object that's outside the realm of the car type to access data. But public is usually needed, so we want to be able to call functions that relate to the class car. Okay. All right, so we will go ahead here. I'll make this same color for you, easy to see, hopefully. We'll go here and look at some features. Private are the members, as we mentioned. Color, years, make, model, trim engine, double for MPG. We put our data types in there. Public for method members. Excuse me. And we usually want to put things in nice little order there. You can define anything anywhere in this area. You don't have to have constructors first, but I put a little label because there could be a lot of functions. It's easier to know, hey, here's where I get things, here's where I change things, and here's where I construct things. What's a constructor? Well, if an object is created, mom's car, dad's car, it calls this constructor by default. This will be fired. One of these guys will be fired. And we have that mentioned before, things can be implicit or explicit. So if I don't define one, are there defaults? Or I may define them and put arguments through, or maybe no arguments, or maybe default arguments. So there's various ways and means to describe how a constructor is set up. I can sort of declare the class, and sometimes if there are very quick definitions for the functions, I can define them right away, no biggie. Boom, boom, boom. It's a simple one-liner or two-liners. But sometimes we want to take things outside the class after we end it with our semicolon and define it because it can get kind of chunky. So if I am going to define a class object, maybe underneath that area there, after the class is defined, then I'm going to put that section in, and notice I use the class name and then that scope resolution operator and then the function. So it's just looking like a function, but we have to sort of say, hey, I wanted to say what that function is part of, so we want to include that particular class name. Okay, and then a basic main. Get that car started, put some values in perhaps, and then make some calls. Going back to my fraction example, if I run this, get a nice display. It's done some computations, and we'll show some output. There we go. Got some output there, so that's a nice little function example of fractions, and we can deal one object against another. So I'll send you this. Pretty cool to follow. It's a really nice program. Notice it's pretty cool. I can even pass objects into the parameters of a function or parameter of a function, and that can evaluate the function I'm calling as an object and the function, the object that I am sort of passing, and collectively I can get that information. What does B have versus what A has? A has a numerator of 1 and a denominator of 2, right? Because that is that's a definition of what the members have. And B has 1 and 4 for numerator and denominator respectively. So I can evaluate each numerator and denominator of an object against each other. And so when I look at a function call, I can check the numerator and denominator and then get some return result. And I use my buddy, the GCD. Oh yeah, very cool. Can help calculate and give a definitive least common denominator result there that I could use for especially the difference and the summation of fractions. Product and division are a little bit different, as you can see. A little bit different how maybe that's calculated versus maybe the difference in the sum functions. It's a pretty cool program. So a little bit of intro, hopefully it helps out a little bit. And we look at the lab number 11 and we can sort of surmise some things we mentioned in our notes. Constructor has the same name as the class. So that is a given. So really I am sort of defining it right here. It's not a huge function. And I'm setting members to 0 for length and width. Notice I have the keyword public as a access specifier name and private as an access specifier name in colons after the name. Those are keywords, so that's why they're in blue. I have two floats, length and width. Why? Because I want to do some calculations off rectangle. I only really need length and width to get maybe area and perimeter calculated. So just like we had other lab examples, we want to fill sort of things in. Here in main, I have certain features that are going to be included that are going to be used for calculating the width and perimeter of a rectangle. So I would like to ask the user for a length and width between certain values. So it's sort of good to sort of error trap that. Do we error trap that at all? We don't, but we should. We want to make sure that's between 0 and 20. So obviously I need some rectangular object. Well, we look at R here, it looks like that's an object because it's going to call one of our methods, one of our mutators, and set values is probably defined somewhere. There it is. It's set up here, but it's kind of long, so it's going to be defined right there. So we probably want to use rectangular R. Yeah, cool. And this, if it's asking for length, well then we no doubt want to get width. And voila, pretty much we have the bulk of main included. Now notice when I call something as a function with my object, sometimes it's a standalone object. If I took this out, it would look like it's a void. So set values, if you notice, is void. It's not returning anything. I don't have an output statement. I don't have something assigning maybe a result to something that's going to be a function return there that's going to be stored in a variable. It's void. So we don't do that. Okay, doke. And then obviously some things can be called in main in the output. And so get width is returning a float. So that can be depicted right here. So once I have an area calculated and a perimeter, you notice r.perimeter, that is going to have a result. And therefore, some area is going to be called and have a result in output here. So once length and width are defined, we can then go to town. We could show individual values with our getters, get length and get width, and I could return my area and I could return my perimeter. Hope this helps. Take care.